Today we'll be doing 5-3 function rules, tables, and graphs. Example 1 is the 3 views of a function. And it says to model the function rule using a table of values and a graph. So one way a function can be written is the equation, y equals -1/2 x plus 1. The second way is to use a table. We have our x in this case, and we have our y. And anytime we're going to graph them, you need to get 2 points at the very least. And I want to make sure that I get whole numbers. So if I look here, I have a denominator of 2. So I'm going to use 0. And then my second number is going to be that denominator 2, so I know that it gives me a whole number. If I plug in 0 here, -1/2 times 0 is 0, plus 1 is 1. Then I do -1/2 times 2. If I look here, the 2's cancel out, and I'm left with -1 plus 1, which is 0. So my table of values gives me the 2 points of 0, 1, and 2, 0. So then I go over here and I graph it. I have 0, 1, and I have 2, 0. And it's in the form y equals mx plus b, so we discussed that if that's true, then it's going to be a straight line. So then we connect our points with a straight line. This one happens to be going downhill. And we should have known that before we graphed it, because my slope right here, my m, is a negative. Put arrows at the ends, and there's your graph. So again, the 3 views of a function is the equation form, the table of values, and the graph. Example number 2 then is your problem-solving word problem 1. And it says, suppose your group recorded a CD. Now you want to copy and sell it. One company charges $250 for making a master CD and designing the art for the cover. There is also a cost of $3 to burn each CD. The total cost, P of C, depends on the number of CDs C burned. Write the function rule for the situation and then make a table of values and graph. Well, it says the total cost is P of C. And we know that it costs $3 to burn each CD, plus it charges $250 for that first original CD. So there is our function rule that it said to write. It says then do a table of values. We have the number of CDs and then its cost. So let's say and you can choose random numbers. I'm going to choose if I have, let's say I have 0 CDs, $250 for the initial. Then if I have, I'm going to go by 100s. I'm going to go up by 100. So if I have 100 CDs burned, it's going to charge me $550. And I'm going to go ahead and put a couple more. Really, you only have to do 2 in order to do the graph, but I'm going to go ahead and keep going. And I'm going to do 200. And that would give me $850 it would cost me. And then I'm going to make the graph. So my graph here, across the bottom is the number of CDs, and don't forget you have to label your axis. Your y-axis then would be your total cost, and I don't know why it's doing that. Let's see if I can get it to work better. And that's in dollars. Okay, and across the bottom, I'm going to choose to go by, and across the bottom I have to go up to 200. I'm going to choose to go by 50s. So I have 0, 50, 100, 150, 200. So my scale there is by 50s, and going up, I have to go clear up to 850. So I'm actually going to go by, let's see here. I'm going to start at 250, so I'm going to skip here. So I put the squiggly to signify I skipped part of the graph. And then I'm going to go up by 100. So there's 350, 450, 550, 650, 750, 850. So 250, 350, 450, 550, 650, 750, 850. And then I go ahead and I graph my points. So I have 0, 250. Then I have 100, 550, and then I have 200, 850. I don't know how accurate this is going to be because I didn't use graph paper. I would suggest you use graph paper, then we're going to connect them with the line. And we put our arrow at the end. So we have our function rule, our table of values, and our graph. Now we're going to go over some vocabulary. The first one is continuous data. And continuous data, is data where numbers between any two data values have meaning. When graphing, let me rearrange this real quick. You use a solid line to represent continuous data. Discrete data then, let me get that where it should be. There we go. Discrete data is where parts don't have meaning. Examples of this would be when you're talking about number of people. Another one would be number of cars, because you can't have half of a person or half of a car. It wouldn't be useful. Okay, and then for discrete data, when graphing, only use points. You don't connect them with the line. Okay, so if we look at our example 2 there, the CD, and we connected it with a line, now we need to see, should we have connected that with a line or not? And if we look here, can you have a partial CD? No, you're not going to burn a partial CD. So, example 2 should have been discrete, because you wouldn't burn a part of the CD. It's not meaningful. So we should not have connected that. Alright, now using that idea of continuous and discrete, now we're going to go ahead and look at a few more examples. Example 3 says, determine whether the function rule models discrete or continuous data, then make a table and graph each function. An automatic photo booth charges $3 for a sheet of photos. The function, C of P, is equal to CP. Describes the cost of P sheets of photos. So we need to decide if this is discrete or continuous. Well, if you look here, it's talking about the sheet of photos. This one is going to be discrete because it will not print off a partial sheet of photos. So our explanation would be it doesn't print partial sheets. Okay, so our table here, we have P, and then we have our cost of the sheets. So P is the number of sheets. So if I get 0 sheets, it costs me $0. If I get one sheet, it costs me $3. 2 sheets cost me $6, and so on. Remember, you have to have at least 2 points there. And then we go ahead and graph it. Our P here, our input, is the number of sheets. And our output then is the cost. Our first point there is 0, 0. Then we have 1, 2, and 1, 2, 3, 4, 5, 6. And these numbers are small enough that I would suggest going by 1. So you have 0, 0, 1, 3, and 2, 6. Because it will not print off a partial sheet, you leave it like this and you do not connect it with a line. The second example here is the function m of w is equal to 1/6 w describes your weight on the moon as a function of your weight on Earth, w, in pounds. When we are talking about weight, you can be half a pound, so you can connect these because it is continuous. Your explanation would be you can measure weight in parts of a pound. Measure weight in parts of a pound. For instance, half a pound, quarter of a pound, all of those. So then we go ahead and we make our table. We have our weight here on Earth, gives us our weight on the moon. Okay, you're not going to weigh 0 pounds, so we're not going to start at 0. Let's say, for instance, we weigh 60 pounds. If we do that, then on the moon we would weigh 10 pounds. Then let's go with 90. We weigh 90 pounds on Earth. We would weigh 15 pounds on the moon. Again, you have to have at least 2 points. I have at least 2 points, so I'm going to go on. W, my input, is my weight here on Earth. Weight on Earth. And we went from 60 to 90. I'm going to go 0. I'm going to go by 30s. 30, 60, 90, and so on. Going up then, it was 10, 15, and so on. So I'm going to go by 5s. 5, 10, 15, 20. And then we graph our points. 60 would weigh 10 on the moon. 90 would weigh 15 on the moon. And then we draw our line because this is continuous. I could weigh a partial amount of a pound. So it's continuous, so you connect it with a line, arrow at the end. Okay, our next part then is all they want you to do is they give you the function and they want you to graph it. We've talked about this at the beginning. This is an absolute value, so I know this one's going to look like a V. We change color so it shows up a little bit better. So I know when I graph it, it should look like a V. This has an x squared, so I know when I graph it, it should be some sort of parabola. Okay, so if I go ahead and I make my table of values, x, y, let's say for x I put in -2, 0, and 2. I need both sides of the graph. That's why I did both positive and negative. So the absolute value of -2 is 2. 2 plus 1 is 3. The absolute value of 0 is 0 plus 1 is 1. The absolute value of 2 is 2. 2 plus 1 is 3. And now I can go ahead and graph it. So -2, 3, 0, 1, and 2, 3. I know I'm going to connect these with a V shape, so they should be straight lines because this is an absolute value symbol. go, and we put arrows at the end to signify that those continue, and our graph is complete. The next one then is an x squared, so it is going to be a parabola. Again, I make my table. I'm going to need some on both sides, so I'm going to use, again, I'm just going to use -2, 0, and 2. Those are easy numbers for me to work with. -2 times -2, or -2 squared is 4, plus 1 is 5. 0 squared is 0, plus 1 is 1. And 2 squared is 4, plus 1 is 5. So we have -2, 5. We have 0, 1. And we have 2, 5. Again, it looks like it's in the same shape, but because it's an x squared, it has to be a parabola. These are a little bit harder to draw. They're not quite as accurate, so if we go ahead and we connect them, it should be curved instead of this straight V shape. And it should look something like that. So that's why you have to pay attention to the original of what type it is to know to graph it with a V shape or a U shape. You can go ahead and complete your quick checks, and then look at your schedule for your assignment that goes with this section.